Hi, welcome back to our third and last example for solving problems in three dimensions. In this example, we're going to use the cosine law to solve what we're looking for. It says Justine is flying her hot air balloon. So Justine is at the top up here in her hot air balloon. She reports that her position is over a golf course located halfway between Emerytown and Fosterville. So halfway between here is Justine, okay? It says that she has an altitude of 1,500 meters. So the golf course is halfway through Emerytown and Fosterville, and her altitude is 1,500 meters above that. That's why we have a nice right angle triangle there, because she's directly above the ground, or directly above the golf course. Okay, Fosterville is 16 kilometers east of Dangberg. So there's Dangberg. Fosterville is directly east, 16 kilometers. Okay, I'm just going to add this in here. That is east. Okay, and Emerytown is 16.5 kilometers from Dangberg in a direction 42 degrees south of east. So south of east would rotate this way. So that's why we have an angle of 42 right there. Okay, that's from there to there. Okay, and we can see Emerytown is 16.5 kilometers along that line. Okay, it says, what is the angular elevation of Justine's balloon as seen from Dangberg to the nearest degree? So if you're standing at Dangberg, to what angle would you have to look up in order to see Justine in her hot air balloon? Okay. So in order to find this angle, I'm just going to mark it down right here. That's ultimately what we're looking for, that measurement. Okay, I have a nice right angle triangle, DGJ. Okay, the height of this is 1,500. So I need one more measurement to find the angle. It's going to be too hard to get the hypotenuse. There's nothing to help with that. But maybe I can find D to G along the ground. Okay. So a couple things I want to point out too. This distance from E to F, if we chop that in half, we get point G. So what that means is these are equal side lengths, here to here and here to here. So, um, so I'm thinking we're going to need to find this from D to G. So we're already given a distance here. So maybe if I could find maybe like the angle in here, and maybe if I can find this length here, I could use that to find this D to G. Okay, this distance here, in order to get that, I need to find the full distance, EF, and then cut it in half. And this shouldn't be too hard to do because we already have this distance, and that angle. So looking at the larger triangle here, we'll find EF. So that's our first step, get EF. Once we get EF, then we should be able to chop that in half and get this distance. Okay? And then we'll need to get angle E. I'm thinking angle E, we could probably do sine law in this larger triangle because we have this angle and we have its opposite length. Okay? I know that's a lot of information, so let's just do things one step at a time. I also find it helpful to draw the triangle that you're going to use because there are quite a few things that are going on in this picture here. So I'm going to draw a triangle DEF. DEF. Okay, and this is 42. This is 16.5. This is 16. Okay, I'm going to call this side length D. I'm calling it lowercase d because it's opposite to the angle D, right, at the vertex there. Okay, so this should be pretty easy to solve for D because this is a side angle side type triangle, right? Side angle side. The angle is sandwiched between the two given sides. So I'm just going to write here, apply cosine law in triangle DEF. to find length D. So the sine law says the one side squared is equal to the other sides squared minus 2 times the other sides times cos of the angle at D, at the opposite to the distance you're looking for. So these always need to be opposites, right? The distance and the angle. Okay, let's plug in what we know. So E is 16, F is 16 and a half, and the angle at D is 42. Okay, plug that all in your calculator, and remember that's giving you D squared, so you have to root it right after. Okay, yeah, I had a feeling it was in degrees. And I'm missing a square here. Okay, always scan it over and make sure everything's correct. Okay, 135.89. Okay, and we'll need to square root that. We'll say 87. So when we root that, we'll say 87. 11.65, I can round that up. We'll say approximately 16 point, sorry, not 16, 11.67, we'll say. Okay, so we just found this distance here, E to F. That would be this distance up here on that larger diagram. Okay, if I cut that in half, I can get this piece here. Okay, so let's do that next. We can say EG is equal to a half of D. So a half of 11.67. I think that works out to 5.835. Okay, so that's approximately 5.835. Okay, so EG, that would be the distance from here to there. Okay, now we want to find angle E. So this angle right here. So we're still going to use this large triangle, DEF. Okay, and I'm thinking we're already given this angle and its opposite length, D, that we just solved. So we should use sine law. We'll pair that up with these two to help us find angle E. So we'll say here, apply sine law to triangle DEF to find angle E. Okay, I always write what I'm looking for first. Sine E over E is going to equal sine of D over D. We know this pair, right? That's this angle and this length. Okay, let's plug in our information. Little e is 16 and sine of 42 over D, what we just found, 11.67. Okay, multiply both sides by 16. That will cancel that out. So we have sine E equals, I'll write it this way, 16 times sine of 42 over 11.67. So angle E is going to equal sine inverse of 16 times sine of 42 over 11.67. Okay, it looks like 66.5 degrees. So we'll just say, we'll just round down 66 degrees for the angle. Okay, so I'm just going to add that up here. We now have this is 66 degrees. Okay, we also found this length, EG. That was, remember that was half of D. That was the 5.835. Okay, so again, remember we're trying to find DG. That way we can get the angle elevation. So we have a nice triangle right here that we could use. So I'm going to go ahead and draw that down, and then we'll solve for DG. So in triangle DEG, let's draw it first before we write our statement. So it's going to look like this, and then like that, then like this. Okay, we found E to be 66. This is 16 and a half. There's D. This little length here, EG, we said that was 5.835. Okay, this is little e. We're looking for that distance along D to G. So in triangle DEG, we'll say apply cosine law to find E. Okay, I'm using the cosine law because the two sides have the angle, the given angle in between them. This is side angle side again, right? Okay, so this time the side I'm looking for, E. E squared is going to equal the other side's squared. Okay, minus 2 times the other sides. Sorry, that's 835. Times cos of the angle E, cos of 66, the angle here at E. Okay, so remember, I always look at it this way. This side length squared, it's always equal to this squared plus this squared minus 2 times this times this times the angle in between. Okay, so you always just use the two sides and the angle in between. And remember, these are always opposite to each other. Angle E and what I'm looking for, E. They're always opposite. Okay, plugging that all in my calculator. This time I'm going to find it. Actually, I'll do it the same way. We'll find E squared and then we'll square root it again. So we'll do 16.5 squared plus 5.835 squared minus 2 times 16.5 times 5.835 times cos of 66, 227.97, and then we'll root that. $15.09, so 15.1. Okay, so I'm going to add that in here on the diagram. That's this distance right here. Okay, on our overall picture up here, that's this distance here. We're trying to find the angle. So what I'm going to do is I'm going to draw this right angle triangle here. This is like a side view, okay, of looking at that distance along the ground on the map and then looking at a vertical line going up to the hot air balloon. So I'm going to draw DGJ. And that should be point D here, right? Yeah. Okay, so D to G, we just found that. That's 15.1. That's this here. Okay, and we're told in the question the hot air balloon has an altitude of 1500. So there we have a height of 1500 meters. Okay. Oh, we have to be really careful here. I just wrote meters up here. That's actually kilometers, right? Those distances were in kilometers. Yeah. So my apologies for that. All these distances I calculated, I wrote them in meters. They're actually kilometers. We'll have to go ahead and just quickly change that. This one too. Okay, those are km. Okay, so just gonna change that right here. This is 15.1 kilometers. Okay. The height, though, the altitude was actually in meters for the hot air balloon. What that means is we should convert this. So there's 1,000 meters in every kilometer, so we need to multiply by 1,000. So I'd move that decimal place over 3, and we would get 15. We get 15100. Okay, because that 1 needs to move over, the point needs to move over 3 times. Okay, so 15,100 meters. Okay, now that those are in the same unit of measurement, I can go ahead and I can just apply tan to find theta, because there's my opposite length and my adjacent. So tan theta would equal 1,500 over 15,100. So tan inverse that to get the angle. .67, so we can round up. I think it says, the question says to the nearest degree, so we should round up to 6 degrees. Okay, now we can just write a final statement. We can say, therefore, the angle of elevation from Danberg to the balloon is 6 degrees. Okay, so that was quite a big problem. Okay, it's very important that we make sure we just label things along the way. Always specify what triangle you're using and what you're looking for, okay, and how you're going to find it, okay? Those are kind of good communication skills. It makes it easy for anyone who's viewing your work to know what you are doing. It'll also help you along the way in case you make a mistake and need to make an adjustment. Okay, that is it for this lesson. Hope you found these videos helpful. I will see you guys later.